Now that you know how to load and save data in Octave, put your data into matrices and so on, in this video I'd like to show you how to do computational operations on data. And later on we'll be using these sorts of computational operations to implement our learning algorithms. Let's get started. Here's my Octave window. Let me just quickly initialize some variables to use for our example. So set A to be a 3x2 matrix, and set B to a 3x2 matrix, and let's set C to a 2x2 matrix, like so. Now, let's say I want to multiply two of my matrices. So let's say I want to compute A times C. I just type A times C. So it's a 3x2 matrix times a 2x2 matrix. This gives me this 3x2 matrix. You can also do element-wise operations and do A dot times B. And what this will do is it'll take each element of A and multiply it by the corresponding element of B. So that's A, that's B, that's A dot times B. So for example, the first element gives 1 times 11, which gives 11. The second element gives 2 times 12, which gives 24, and so on. So this is the element-wise multiplication of two matrices. And in general, the period is usually used to denote element-wise operations in Octave. So here's the matrix A, and if I do A dot caret 2, this gives me the element-wise squaring of A. So 1 squared is 1, 2 squared is 4, and so on. Let's set V to a vector. Let's set V as 1, 2, 3 as a column vector. You can also do 1 dot over V to do the element-wise reciprocal of V. So this gives me 1 over 1, 1 over 2, and 1 over 3. And this works too for matrices. So 1 dot over A gives me that element-wise inverse of A. Once again, the period here gives us a clue that this is an element-wise operation. You can also do things like log V. This is an element-wise logarithm of the V. E to the V is base E exponentiation of V's elements. So this is E squared E cubed because this was V. And I can also do abs V to take the element-wise absolute value of V. So here, V was all positive, but it did abs, say minus 1, 2, minus 3. The element-wise absolute value gives me back these non-negative values. And negative V gives me the minus of V. This is the same as negative 1 times V, but usually you just write negative V instead of negative 1 times V. And what else can you do? Here's another neat trick. So let's see. Let's say I want to take V and